Welcome back, Algebra. Today we are going to be learning about our last type of function for Algebra 1. So we're going to be graphing rational functions today. You guys got your Waggle logins yesterday. Those are going to be used in Ms. Carlson's class. Just reiterating from my email, we're going to continue with our book, finish chapter 12, and then go on to spend the rest of the year reviewing Algebra 1. I want you guys to be the most prepared to test out of algebra next year. My goal is for all of you to go right into geometry and continue your studies with whatever path you want to follow. So let's get started here. We're going to be talking about rational functions. And a rational function is a function where it has a variable in the denominator. Okay, so it has a variable, that variable x, in the denominator. Okay, remember that a rational number is just any number that can be written as a fraction. So if I have x in the denominator, then that means that I'm going to have a fraction here. So what this looks like is, remember yesterday we talked about inverse variation. So you have something like y is equal to k over x. So that is a very simple rational function here. I have this x value in the denominator, and so this here is a rational function. And rational functions are going to produce what are called asymptotes, okay? Asymptotes. And asymptotes is a line that the function approaches but never touches. Line that the function approaches but never touches. And we saw these before. Remember when we graphed I can draw one right here, but remember when we graphed exponential functions, we had something like this here, right? And then, let me get a different color so you can see it very well. Then we had something like this. So notice here that your graph here approaches the x-axis and it approaches the y-axis, but it never touches either one. So that's an example of an asymptote, is that your graph will approach that line but never touch it, okay? And so let's look at an example of some asymptotes. So for example, if I have this graph here, this first one is, let's graph y is equal to 1 over x. And we're going to do the graphs in just a moment, but I'd like to show you here what this graph is going to look like. So it's going to, they're going to be, let me draw that a little bit better. All right, so this graph is going to come down here, and it's not going to touch the y-axis or the x-axis. Those are your asymptotes. And then it's going to come across this way in two different directions for the negatives and the positives, okay? And so here in orange, these here are going to be the x-axis and the y-axis are your asymptotes, okay? Asymptotes. And you've got two of them, okay? And so we could do another example here. What happens though if we start adding some additional values? So for example, if now I have 1 over x minus 2, well, that's going to shift your asymptote, okay? It's going to shift it over. So here my asymptote is going to be at x is equal to 2. So whatever you add in the denominator is going to shift your asymptote over, okay? Like this, something like that, okay? And so let me draw those asymptotes again. This time it's going to be at x is equal to 2 here. I'll draw them thicker so that you can see them, okay? And these are the asymptotes here. So we're going to do some examples. I just wanted to show you what those look like as we talked about the definition, okay? So we're going to be graphing rational functions that look like this. They have two pieces, right? One that goes in two different quadrants, okay? And they are separated by those lines that the function will approach but never touch, called the asymptotes. All right, let's scroll on down and look at this first example. On a trip, the time you travel in a car varies inversely. So remember from yesterday, as one goes up, the other goes down with your average speed. And that makes sense. So if you drive faster, then it takes less time for you to arrive where you're going. The function t for time is equal to 40 divided by r, which is the rate of speed, models the time it will take you to travel 60 miles at different rates of speed. Okay? I'm sorry, this number here should be 60. Let me fix that here. Here we go, at 60. And so let's graph this function, okay? So we can graph this function by making a table of values, okay? So let's think about this. You can't go a negative speed, right? So we're only really interested here in the in positive values. So let's do a rate and time. Okay, so if we're going to go 10 or 20, 30, 40, 50, up to 60 miles per hour. Let's see how much time it would take. So now you can plug these in. Okay, so for t, now t is going to be equal to 60 divided by 10, which is 6. Now I have 60 divided by 20, which is 3. 60 divided by 30, which is 2. 60 divided by 40, right? Come over here and get an accurate 1.5. 60 divided by 50, here I can make this smaller so that you can see it together. Okay, 60 divided by 50, 1.2. So you notice here that these numbers are going to get closer and closer together, and then 60 divided by 60 is just 1. So I can come over here to my graph. I'll do something a little bit brighter so that you can see it. And let's graph here. So x is my r value, that's your rate, okay, and y is time, okay. And so if I'm driving 10 miles per hour, let's just go by tens here, 10, 20, 30, 40, 50, 60. If I'm driving 10, it will take me, 1, 2, 3, 4, 5, 6 hours to get there. If I'm driving 10 miles an hour, okay, to travel 60 miles. If I'm driving 20 miles an hour, now it's only going to take me 3 hours. 30 miles an hour, it will take me 2 hours. 40 miles an hour, 1.5. 50 miles an hour, 1.2. And 60 will take me 1 hour. Okay, and that makes sense, right? 60 miles an hour, if I'm driving 60 miles, it takes me 1 hour. Now I can connect these dots, and notice in this one that my asymptotes are going to be at 0, because for both time and your rate, because you cannot go less than 0 miles an hour, okay, here. So this would be an example of this graph here. All right, and we're not interested in the negative values here because, again, we're talking about distance and time, neither of which can be negative. Okay. All right, let's move on. In this next one, we're going to identify the vertical asymptote of y is equal to 4 times x plus 3, and then we're going to graph the function. So in this case, we are going to be interested in those negative values because we're talking about a function that we don't know what the context is. We're not sure what it's related to. So here, it's going to be important that we need to find the asymptote. So step 1 is going to be to find that vertical asymptote. And I'm just going to abbreviate asymptote. V for vertical, and your vertical asymptote is going to come from the denominator, okay? Set that denominator equal to 0, and remember that the asymptote is where the graph is going to approach but never touch. And the reason that you want to set it equal to 0 is that we know that denominators cannot be 0 because you cannot divide by 0. So if I plug in 0, let the denominator be 0, then I'm going to find the value that will never satisfy the function. So if I solve for x here, x is equal to -3. Okay, you're going to subtract 3 from both sides. So I'll come over here to 1, 2, 3, -3, and here's my vertical asymptote, because this graph will never exist here, because this value here can never be 0, because you cannot divide by 0. It's undefined. All right, so we've just found the asymptote to be at x is equal to -3, and then step 2 is going to be to to make your function table in order to graph. So when you're making your function table, usually I tell you to use -2, -1, 0, 1, and 2, but this time I want you to choose values that are around the asymptote. So if your asymptote is -3, I want you to choose at least 2 values that are less than that and 2 values that are greater than that. So we should choose, if we choose 2 values that are less than that, then we can choose, let's see here. Let's choose -4, -5. And then we need some values that are bigger, -2, -1, okay? And so if I plug in -5 now, then I'm going to have 4 divided by x, which is -5. Let me plug that in here. So this will be -5 plus 3, which is 4 over 2, which is 2, okay? I'm sorry, this would be -2, -2. And then the next one, 4 divided by -4 plus 3, which is going to be 4 divided by -1, which is -4. 4 divided by -2 plus 3, I'm kind of running out of space here, which is going to be 4 over 1, which is 4. Okay, and then the last one, so I'm kind of off here in my chart. Let's see if I can try to organize it a little bit better. I'm not sure. Let me see if you guys, yeah, we're kind of running out of space. Let me scroll down just a little bit, lose the top here. And so for then this last one here, this is -1. I can move this guy down so you can see it better. Then I have 4 over -1 plus 3, which is going to be 4 over 2, which is now 2. Okay, so let's plug these values in here at -5. So here's 3, 4, 5. I'm now at -2, 1, 2. Okay, and -4 is at -4, 1, 2, 3, 4 here. Okay, and remember that these graphs, and actually we probably should go one more. Let's also do, I think if you go 3 in each direction, that's going to give us a better curve. So if you plug in -6, you should end up with -4/3. Okay, so come over here to -6 and -4/3, which is -1 1/3. So -1 1/3 about here, because that's going to help you create this curve that you're looking for. So it's going to come down towards the asymptote this way, and then approach but never touch this x is 0 over here. Oh, I touched it. Oops. Oh, that's because I know why. This dot was not correct. -1.3. Here we go. All right. Now this is looking more accurate. Something like this. Boop. There we go. And then on the other side, we can graph -2, 1, 2 is going to be at 4, 1, 2, 3, 4 up here. And -1 is at 2. Okay, and go ahead and do 0. So 4 divided by, if I plug in 0, that should give me the +4/3, which is a +1.3 bar, 1 1/3. So 0, 1 1/3 here. And then 3, I definitely think I want you to do 3 in each direction, because then it gives you that nice outline to draw your curves. Okay, so here's the graph. And so we have a vertical asymptote, which we found to be at x is equal to -3. Okay, and your horizontal asymptote here is, it didn't ask for it, but notice here that the horizontal asymptote is at y equals 0. Okay, so the vertical asymptote occurs where x is equal to b, or well, we'll show that in just a second. So your vertical asymptote, you need to set the denominator equal to 0 to find it. Okay. All right. Let's move on and do another example. This time we want to find both the vertical and the horizontal asymptote. So we can start again with the vertical asymptote, set the denominator equal to 0. So the vertical, okay, we take this here, x plus 3, set it equal to 0, which we already then determined that x is equal to -3. So we can come over here and draw that same vertical asymptote, but notice here that I have something different. Okay, I have now added a +2 on the end. Okay, that's where we're going to find our horizontal asymptote. Okay, so your horizontal asymptote comes from this extra piece here. So I'll put an H for the horizontal and a V for the vertical. So your horizontal is going to be at y, because it's a horizontal line, is that y is equal to 2. Okay, so whatever you're adding or subtracting here is going to become your horizontal asymptote, because you're shifting the graph either up or down, okay, whenever you add a value at the end. So here my horizontal asymptote is going to be at y is equal to 2. Okay, so y is equal to 2 is your horizontal, x equals -3 is your vertical, and now we can create up our graph. So again, we're going to choose, like we said, now that we're going to choose 3 values smaller and larger than your vertical asymptote, which was -3. So if I choose smaller, then that's going to be -6, -5, -4, and then larger is going to be -2, -1, and 0. So we're kind of skipping out -3, because it's not going to exist at -3, because that's your asymptote. That's where the denominator is going to be 0, and it's going to produce an undefined result. Okay, so for the y values, y is equal to 4 over x plus 3 plus 2. Now notice here that we already did at 4 over x plus 3, and we got those values already. Remember, when we plugged in 6, we got -4/3. So now what we're going to do, which was -1.3 bar, so now what we do is we could just add that extra 2 on the end, because we already did this beginning portion here. We are in the previous example. So -1.3, and then if we add, let's see, 0 minus 1.3, and now we're going to add 2, so you have 2/3 is what we're left with. Okay, so 2/3, which is the same as 0.6 bar. -5, when we plug that in, we got -2. Now I'm going to add 2, which is going to be 0. We plugged in -4, we got -4, add 2, so that's going to be 2. At -2, we had +4, add 2 again, which is going to be 6. -1 was a +2, add 2, which will give you 4. And 0, we had a +1 and 1/3, add 2 to that. Now we have 3 and 1/3. Okay. All right, so hopefully I didn't confuse you. I was just kind of saving us some work, because we already did the beginning of that function. Now we can graph it. So at -3, 4, 5, 6 over here, we're going to be at 0.6 bar, which is right about here, about 2/3 of the way. And at -5, we're going to be at 0. And at -4, we're going to be at, this should be -2, at -2 here. Okay, -2. Now I can draw my rational function. It should curve but not touch my asymptotes. Okay, now we can come over to the other side of my asymptote, and at -2 I'll graph 1, 2, 3, 4, 5, 6. Okay, -1 is going to be at 1, 2, 3, 4, and 0 will be at 3 and 1/3, about here. So again, I'm going to draw my curves and approximately go towards but never touch my asymptotes. And here I have my graph of my rational function. Okay, so this concludes what we're doing today, which is graphing these rational functions. You need to find the asymptotes. I do want to just write here that this is the standard function. So we're going to come down here and we're going to write a summary of all of the functions that we've learned so far. So notice here that today we did rational. Okay, so the rational function, and it looks like this. In its proper form, standard form, is y is equal to a over x minus b plus c. So you have some fraction, and then you could be adding a value. In that first example, or when we talked about we had x equals 1 over x, that's still a rational function. The number that you're adding on the end is 0. Okay, so remember 0 is the number 2. And here you have your vertical asymptote. Your vertical asymptote is going to be at x is equal to b. So that comes from the denominator. Remember that x is equal to b, okay? And then, and then your horizontal asymptote comes from that c value. Horizontal asymptote is going to be at y is equal to c value, okay? And what makes a rational function is that the variables have to be in the denominator. Variable in denominator is what makes it special, okay? I do want to finish this sheet here so you have a nice summary of all of the functions that we've learned in Algebra 1, okay? You're going to be expected to be able to identify these from the pictures of their graphs. So a rational function looks something like this, and we're just going to draw some sketches here. So the first one that we always studied is the linear function. Remember, y is equal to mx plus b. And what's special about that is it's always going to produce a straight line, okay? Where m is your slope and b is your y-intercept, okay? Y-intercept. And notice on these that the slope is always consistent, right? It's always increasing or it's always decreasing, okay? And the key as well is that your exponent on your x is always going to be 1, okay? So this is always here. You can only have your exponent be 1 in order for it to be a linear function, okay? Then we learned about quadratic functions was the next one, where your highest exponent is a 2, so y is equal to ax squared plus bx plus c. We studied these quite a bit. They produce a parabola shape, okay? And with here, you also have an axis of symmetry. Remember that where the parabola, one half of the parabola mirrors over. And that axis of symmetry, if you recall, is that x is equal to negative b over 2a. And I'm just now realizing that my camera is in the way, so let me move that out of the way for you. There you go, so that you can see. So quadratic function here, y is equal to ax squared plus bx plus c, and then produces this parabola shape with your axis of symmetry at x is equal to negative b over 2a, okay? And so let's scroll down and continue. We also learned, let's choose green now. Then we learned about, let's do exponential functions next. Okay, an exponential function looks like this. Y is equal to a to the a times b to the x power, right? Where a is the initial value, starting value, and b is either your growth or decay factor, right? Growth means that you're going to be increasing, and that means that b is greater than 1. And your decay factor is when b is in between 0 and 1, okay? And the variables in the exponent here. And an exponential function looks similar to a rational function, but it only has one side, I guess you could call it, okay? All right, then we talked about, how about orange now, absolute value functions. Remember those? Absolute value, which, what do you think is going to have? Absolute value symbols. So y is equal to, okay, x minus a plus b, okay, where the a value shifts it horizontally, which means left or right, and that b value is going to shift it up or down vertically. Shifts vertically. And your standard absolute value, y equals the absolute value of x, remember, produces a v-shaped graph like this. Okay, so if you add an a value, then you would either be moving this left or right, and if you add a b value, you would be moving this v shape up or down. Okay, so that's what it means by shifting horizontally and shifting vertically. Okay, and your vertex for an absolute value function is at AB. Okay. All right, and the very last one that we learned is going to be a radical function, which we did last chapter. A radical function. And a radical function looks like this. Y is equal to the square root of x minus b plus c. Okay, and it would look something like this here. And remember that your that b value is going to shift it horizontally, meaning left or right. And I think I'm covering it up again. I'm sorry. Let me move. Here we go. There we go. And I can move myself out of the way. Boop. There we go. Okay. Shifts it horizontally, and the c value shifts it vertically. Okay? And so that's your summary of everything that we learned from Algebra 1 as far as the functions go. So this is really important stuff here. Make sure that you have a good understanding of each of these functions. We're going to go back and be reviewing them after this chapter, but this is the last type of function that we're going to be learning, all right? So I'm going to assign your homework today. It won't be due till tomorrow night because usually you have the weekend, but I do want to get grades updated so by Monday. So if you could turn it in by Saturday night, that way that I can get those graded for you. All right, have a good weekend. Bye.